All right, so I'm going to use Desmos to show you how to graph the function you're having issues with, and you want to use transformation of functions. So we want to start out with the basic sine of x, and you may be familiar with this. It should be going up from the origin, and has a period of 2 pi, amplitude of 1. So you notice that this point right here is 2 pi, 0. So that should make sense. Now, the first part of the transformation, we want to deal with the -1. And you should be familiar, or actually, sorry, we want to deal with pi x, the pi portion. So we have y equals sine of pi x. And notice, and should be familiar with this, that multiplying by a constant inside the parenthesis changes the period. And so you'll notice that multiplying by pi, to find the period, you divide by that thing we're multiplying by. So the period goes from 2 pi, and then you divide that by pi, you end up getting a period of 2. So you'll notice that that's our period now, from 0 to 2. So a period of 2. And so now let's move on to the next part. We have y equals sine of pi, and then x minus 1. And from this, we get the green function here. And -1, you should be familiar with -1 and how that works with other transformations back from algebra. When you subtract 1 inside the parentheses, that the horizontal shift in the opposite direction. So that's a horizontal shift to the right 1 unit. So you'll notice that where we had the origin 0, 0, that point has from the blue function, we're going up from the previous function. Now we've shifted this point over to the green function here, and it's going up from here. So you'll notice that you have the same sort of pattern. It's kind of weird to look at sine and think of transformations involving shifts, horizontal shifts especially, because it's just a wave and you don't really see where it's going. It's not that obvious, but it's a shift to the right 1 unit. Okay, so that's how we end up getting this green function. Now you'll kind of notice that this might be where you're getting confused. I'm not really sure, but yeah, we're no longer going from the origin going up. Now we're going down essentially. So it's kind of like the negative sine function, but we get that from just subtracting 1. Okay, so the next part of this function, you want to think of the order of how things work out. So notice that we wouldn't add 2 next. We would multiply by the number in front of sine, and then we add 2 at the end. So the next part of the transformation is y equals sine of, I'll just write this down again, and then I'll show you what we're adding into it. Okay, so now we want to multiply by the number out in front, which is 2. Okay, so notice that when we multiply by 2, compared to the green function, it's just taking the output, and we're doubling anything we would have got from the green function, the previous function. So notice that 1, like this point right here, this 1, input negative 1/2, and we get 1 out from the green function. That doubles, and now we're at 2. And 0, 0, because double 0 is 0 for both the green and purple function. But notice that we're down at -1, and that doubles to -2. So that should make sense that if you multiply by 2, the output just doubles. So it's like a vertical stretch when you multiply by that 2. And then the last part of this function is that add 2. Actually, I'm going to just copy this function, write it again. And now we're just going to add 2 and see where the orange moves to. It's a vertical shift. You should remember, because we're from transformations back in algebra. We add 2, and the purple function just moves up 2 units. So that's where we get this function from. You want to take these steps in the transformations. There's a lot going on. We see 5 different graphs here, but if needed, I mean, these are the steps you want to take. We're taking 1 step at a time to get to our using transformations to get to our final graph. I would not advise doing this all in 1 step, trying to to find the graph, it's almost impossible. I mean, it's really hard. You want to take one step at a time to get to our final graph of our function. All right, so hopefully this answers your question. Let me know if you have any other concerns.